Now this section is called Working Mathematically. I'm not a huge fan of that title because, to be honest, I feel like that's the whole thing. Isn't everything working mathematically? Like, what's the rest of it? Just sitting around mathematically? Anyway, what makes these problems different from the rest? What makes them different? Okay? Any suggestions? Apart from the fact that they're harder, I'm trying to work out why are they harder? Why are what qualities do working mathematically questions have that make them more difficult? Yeah.
Like 2 steps, and they have more steps than...
Yeah, okay, so I guess we could say they're more complicated. Or there's more steps. So instead of, you just have to do the one thing and then you're done, you move on to the next one, okay? Often there's a process you've got to go through, and the problem isn't just simply very quickly solved. You've got to sort of stay with it for a while, okay? 7th of May? 7th of May.
Yeah.
We're ready.
Alright. Yeah, the year's racing by.
Thank God.
Now, not only that, when you have a look at some of these questions, right? They don't provide all the information, right? Or the information they provide you is sometimes it's unclear how it's useful, right? So for instance, if you have a look at this sheet, even from where you're sitting, right? You can see there's some diagrams here, yeah? But not all the questions have diagrams, even though they do involve some shape or geometry, right? So these questions at the top here, for example, the very first one we're going to do, doesn't provide you a diagram, but you really need one. It's almost impossible to solve it effectively and make sure that you have an accurate answer without having done that, okay?
You could add big to my thing.
Okay. Now, those I think are sort of the critical things. Let's do the first one together. Number 1. Okay. Now, as usual with working mathematically problems, right? Because it's more complicated, right? One of the things that will help us is to look, and as you go through the question, right, you try and express or articulate what's there on your paper. As you do that, you start to understand it better. It's a little bit like when you're having a conversation with someone. I don't know if you've ever experienced this before, but if you're talking to someone and what they're trying to explain to you is difficult, tip for you, one way that's helpful, is you try it during the course of the conversation, you say, they talk for a minute, and you say, now, let me see if I get this straight, and you try and say it back to them in the same words, okay? It's actually a really good listening skill. It'll help you rather than all the information like washing over you, you'll get an idea of what's going on. So let's read, and then start to put pen to paper. A point is chosen at random on an interval of length 25 centimeters. A point's chosen at random on an interval of length 25 centimeters. Now, at that moment, before I go any further, I'm going to stop, and I'm going to put a drawing on here, right, which will explain or just, represent what I just read. So you've got an interval. How long did they say it was? 25 centimeters. So, I beg your pardon?
Should we copy this as well?
Yeah, I think it's a good idea to keep up with it. 25 centimeters from end to end. Okay? And then I think they said at the start, a point is picked at random somewhere on this interval.
Just put it right in the middle.
Okay? Now, I'm not going to put my point just yet. I will put something in the middle.
Yeah.
But, I mean, the point of saying it's picked at random means it could be anywhere. It could be anywhere. Okay? Now, let's move on. Next sentence. It says, find the probability. Okay, again, stop. As soon as you see the word probability, right, you immediately know there's going to be some kind of fraction involved. Now, what are the pieces that make up the probability fraction? There's something on the top, we divide by something on the bottom. Does anyone remember what the two bits are? Okay, so the numerator, what are we expecting it to be? There was a phrase here.
Summing under 25.
Excuse me.
Bless you.
Thank
Bless
you.
you.
Favorable outcomes. In other words, what are the parts that you want? Right? What are the things that might happen which you're interested in? That's going to be the numerator. Okay. What's the denominator?
The length.
Now, I'm going to write down the length, but what it represents in a probability question. I don't know which is worse. Sneezing a lot, or almost sneezing, and then your body decides,
So what
I'm
does
good.
have to favorable?
Favorable outcomes, right? Or favorable events, if you like. On the denominator, it's all the total events. We have a name for this. It's called sample space. It means everything that can possibly happen. Okay? Now, when I say everything that can possibly happen, The question gives you some examples of what can happen and what can't. Yeah.
Sorry, what was that word on the top? Favourable outcomes?
Yep, that's right. Favorable outcomes, sample space. Okay. So for instance, a point like this is not part of the sample space. Why not?
It's not good.
It's not on the line, interval, right? Because they said a point is chosen at random somewhere on here. So this is not an option, and this is not an option, and this, all of the possible outcomes, the sample space, are on that line. Okay, is that all right so far?
Yeah.
Good. Now we keep going. We've said this is a probability, right? That the point is more than 6 centimeters from the middle of the interval. That the point is more than 6 centimeters from the middle of the interval. Okay, again, I'm gonna think about how I can represent that here on what I've drawn. Okay, where's the middle of the interval? You just sort of can draw it in, right? I guess if you it'd be 12.5 centimeters from one side, 12.5 from the other. So I'll put that there. Okay, that's the middle. All right. Now, then they say, what's the probability that it's within 6 centimeters of that? 6 centimeters from the middle. 6 centimeters from the middle. Okay. Now,
On which side?
which side is a very good question, right? Now, for instance, let's put a point like, say, here. Now, I know I haven't given you a scale, but say for argument, it's like 2 centimeters from the middle, okay? Does that fit what they're asking? Is that a favorable outcome?
No. What is a favourable outcome?
Let me read it again. Find the probability that the point is more than 6 centimeters from the middle. You're correct. It's not favorable. It's too close. I want to be further away, don't I? Okay. So I want to, yeah, that's right. I want to be 6 plus, okay? So for instance, where would 6 be? I mean, I get maybe somewhere like here.
Nah.
Is that okay?
A
Roughly.
little bit more to the left side. Oh.
Okay, now let's talk about both sides in a second. Anywhere in this spot, you're busted. I'm too close to the middle, yes? But I can make the same argument going to the right as well as the left, right? I can say, you know, I said 2 centimeters to the left in the first case. If I went 2 centimeters to the right, I'm still in trouble. I am not far enough away, okay? So I'm going to go 6 centimeters to the left, and I'm also going to go 6 centimeters to the right. Okay? Now those areas there, I don't want to be in there. I don't want to be in there. I want to be outside that, further away. Okay? So therefore, to mark that in, I'm going to put that in another color. Maybe you've got like a red pen or something like that. Okay? This part over here, okay? That's good. That's far enough away. That's favorable. Okay? And I've got the same thing on the left-hand side. Okay, so if I'm anywhere in that green shaded area, I'm good. Okay, those are the favorable outcomes. Now, the question then is, how much of the line, the interval, how much of it is green? How much of it is green? Now, I don't have any measurements on here, right? But I do have measurements in here in the middle, don't I? Okay, what was this area that I wanted to avoid? How long is it in total?
12.
It's 12 centimeters, 6 one way, 6 the other.
That's
So
25
this area here, 12 centimeters, that's what I want to avoid, okay? So when I say, what are the favorable outcomes? It's going to be the whole length, take away that bad spot, the spot I want to avoid. Take away 12. Is that right? You see what I've done? That's how I've worked out what the favorable outcomes are. They're the outside, they're the leftovers, if you like. Now, what's the total sample space? Well, we said it's anywhere on the line. It's the length. It's 25. Okay. Now, if you liked, I suppose you could have said centimeters here and centimeters here, but because it's a fraction, the centimeters, the units would just cancel. Okay, probability doesn't have units attached to it, even though this question, it does. Okay. So 25 minus 12, of course, that's equal to 13. And can we simplify this fraction anymore?
No.
Is there anything we can cancel?
No.
There isn't, is there? And that's partly because 13, that's what we call, if you remember, a prime number. So it doesn't have any factors with anything, really. Just 1 and 13, that's it. Okay. So how do we approach this question? Well, the first, probably the most important thing that I did was I drew a diagram, right? All of the argument that we've made, and hopefully all the logic that makes sense to you, depends on there being a diagram. I could try and do it in my head, It's just a lot harder to see.
That's why it's complicated.
Yeah, that's right. So you see, they don't give you a diagram. They're expecting you to be able to interpret the information that's there, make your own one.
Now,
Okay.
that might take about 45 minutes.
Yeah, that does take time. It is more time consuming, okay? But, you know, this process of putting together a diagram that you've never seen before, okay, even though you're not used to it, it's a skill that can be practiced just like any other,
Isn't
okay?
that what they basically want you to do in the test?
You mean draw a diagram,
Yeah.
and then, yeah, that's right. And particularly you will see diagramless questions under working mathematically, even though they do need a diagram, okay? So whenever you hear or read, okay, there's some measurements or there's a shape involved, the first thing you should do is start drawing, okay?